It's been quite a while since my previous video on this project, but that doesn't mean I haven't been working on it. But I've been busy with other things, and I want to present this video, which is going to be focused on AWS infrastructure, and in particular, setting that infrastructure up with Terraform, and then using a GitHub workflow for the continuous integration and continuous deployment. There's actually a lot to cover, and I'm not sure I know the best way to cover it, but let's start by looking at the application from the user's point of view once again. So in this aspect, other than the fact that now that there are domain names involved, because this is now a hosted application, not whereas before it was a locally running one. Otherwise, feature-wise, in terms of the user experience, it's the same. But let's just for sake of refreshing your memory, let's see what happens. So if we go into the network filter, load a page, and we see that products are loaded from this domain. Is that too small to be legible? I'm not sure if I can zoom in on that. Yeah, okay, I can zoom in on that. But then I have to move this so you can see it. So yeah, there is a hosted endpoint that is involved here. So, and you're not seeing actual direct interaction with the database. You're seeing that this is a hosted API, and that API is returning the results. For instance, it's returning So here we're returning a list of fruits. The remote address is here. This is HTTPS connection. It's actually going to a load balancer, and up here, notice that it's not secure. At this point, I don't have the web server running in secure mode, so that's just an HTTP connection. So there we go. That's the application from the front end point of view, user's point of view. Let's look at a diagram that I drew. Let's see if I can make this fit in the window. Is that legible? Well, I'll zoom in and out as I need to. So you can see that in Route 53, this diagram represents AWS infrastructure. This project didn't need to be all on AWS. Terraform can work with other kinds of providers, other kinds of systems, but in this case, I've just used AWS. And so the domain name I've registered on Route 53 is onyxdevtutorials.com, and then I created these subdomains, one for the front end, one for the back end, one for the API. And you can see that in this diagram, there's lots of stuff, right? So where do you start when you're setting up a project like this? You can think about you've got this application that could run in any number of ways, but you know you're going to need a web host. You know you're going to need this backend service API running. And my decision was to create them as Docker services, front end and back end Docker service. I knew I needed to have a database, and I needed to be able to connect them to the outside world, but I wanted to kind of isolate them too, for the sake of security. So a VPC is a good way to set all this up. So in AWS, you can create a VPC of your own, and you can define within it availability zones. So obviously, well, not obviously, but okay, you've already got the concept of a region. So I'm in US East 1, but you also have the concept of availability zone. So you, for the sake of robustness, reliability, in case one thing fails or you have something to fall back on, you can have multiple availability zones. I created 2 availability zones. At this point, I'm not really taking advantage of the fact that I have 2, because I'm just running one instance of each of my services, but we could easily change that. But let's say, just for the sake of the future, I've created these two availability zones, A and B, and 2 subnets, public subnet A and public subnet B, private subnet A and private subnet B. So we need this internet gateway. This is this thing that allows the connection to the public internet. We have this private subnet, which we can put our applications in, like our database instance, our front-end service, our back-end service, and they can communicate to the outside world via this NAT gateway. And communications can come in through the load balancer, which is in the public subnet. There's one other way, one other means of communication that I created, which is a Bastion host. I think they have other kinds of names too, but anyway, in this case, it's an EC2 instance where access is restricted to just my VPN, or the VPN IP, right? So just my own connection, and the connection is only via SSH. And this is not strictly speaking necessary, but it can be handy for debugging things, and I used it in particular to be able to run queries on the database and see that things were being set up the way I expected. So I wanted a way to connect to the database instance. So what else? Now we can, so that was a kind of a outside-in perspective, like thinking about it from the user's point of view and connecting in and so on. I guess another way of thinking about it is that you're developing this application, you create your Docker, you Dockerize your applications, or Dockerize your front end and back end, so that these things are now self-contained and portable, and you could run them theoretically on any machine, my machine, your machine, any server. And what I did is, of course, I can run it locally, but also I can put these images of my application, like Docker images, into the Elastic Container Registry of AWS, and then those images can be run in an ECS cluster, where ECS stands for Elastic Container Service, I think. And that is running them analogously to the way Docker, what is it called on your Docker desktop, analogously to the way Docker desktop would run them. So what are the concepts that are involved here? Well, security groups is another important concept that, well, by obviously, you can infer this from the name. It has to do with security and kind of isolating your services in a way that limits access to them to the minimum. So for instance, in my load balancer, ingress can be on port 80, port 443, and port 3000. Egress can be is all of them. So in on those specified ports, out on any port. Another security group is front end, where ingress is 80 and 443. Egress is all. Back end is only from port 3000 and only from the load balancer. I just wanted to double check something, and I'm looking now at the Terraform configuration file for the security groups, and wanted to verify that even though the diagram doesn't say it, I've limited ingress to the front end not only just to port 80, but also and for port 443, but also to the load balancer. So even though it doesn't say that on the diagram, that's what I have. So what else do we have? A security group for the database. Let me check this. Okay, I noticed I had a few more edits to make on the diagram. So the DB security group, I added that not only from the Bastion, but also for the back end, of course. That's the whole point of the thing. From Lambda, which is this Lambda function I used for migration to set up the database. And Bastion group is a security group that allows ingress from port 22 from my VPN IP, and the Lambda. Oh, that's not right. More edits. So the Lambda security group, I think it needs the port 443 egress to be able to get the SSM parameters. We'll look at this later. And egress to port 5432 to access the database. We have public and private route tables. Well, one important concept is that when you set up the VPC, you allocate a block of IP addresses, and here I've allocated far more than I would ever need, 65,000, and then each subnet has its own block of IP addresses that it can use. Again, more than you'll ever need, but they're there. And the public route tables allow connections to the internet gateway and the NAT gateway. Is there anything else in this that I want to talk about? I don't think so. I think that's it for the diagram. So Terraform. What is Terraform? Terraform is infrastructure as code tool that allows you to define and provision infrastructure using a high-level configuration language. And of course, as I said earlier, it's not restricted to AWS. You could use it with all sorts of other providers. By itself, there's nothing in Terraform. Well, you could use Terraform and create one really big monolithic file that does everything for you. So there's nothing inherent in it to like force you into a good practice, I guess I would say. So one good thing. Okay, why would you use Terraform? Well, obviously you could set up your infrastructure just using the AWS console. There's lots of UI there you can use, and let's say you could even do a good job documenting what you've said and why you've said it, but it's pretty unwieldy if you go that route. Especially if you work with a team, or if you have people leaving your organization, or even you yourself, you may not remember why you did a particular thing, and you might just look at this particular service and kind of forget how it relates to other things. The great thing about Terraform is that it can allow you to organize these things in some kind of semi-coherent way and kind of document them and so on. So what I did is follow a pattern of environments and modules. So if I look in my directory, well, you can see it here. Terraform is kind of at the root of my project, and then I've got an environments directory, and within that a development directory. And my idea was that if this were a real project instead of kind of a demo learning exercise, I could create development, stage, production environments. And each could have their own set of variables. You could even create some that have the same variables, or you could, distinct variables for each one. And the reason you'd want to do that is because maybe for development you need fewer resources, and so you don't want to spend extra and have all kinds of CPU and memory and disk space and so forth. Maybe you just don't need those things. On the other hand, maybe you do want some things to be very similar because you want to be confident that if something works in development and staging, that it's going to work in production. Okay, so let's start talking about the Terraform configuration at a relatively high level. And then you are free to take a look at the repo and use anything you find useful, or learn from it, whatever you want. I think the setup that I provide here is, in a sense, pretty generic. I mean, in a good way. That is, could serve as a kind of template for a lot of kinds of applications. So here we are in main.tf, environments/development/main.tf. In most cases, I've put all the resources within modules, but in particular cases, I just put the resource in this main file, like here, the AWS Route 53 zone, and I defined the top level domain that I'm using. And here, provider, and each of these things is called a configuration block. In this provider block, I'm setting up AWS as a provider, and Terraform works with all sorts of providers. This could be Google or some other provider, and you can combine providers. In this case, I'm just using AWS, and then telling it the region and what profile I'm using. So where is it getting those values? Well, there's a variables file here, And you can specify some default values here. That's one way of providing the variables. There's another way too. Maybe at least two other ways you could do it. You could do it from the command line. You can also do it from a .tf-vars file. There may be others, but those are the ones that come to mind right now. So I'm setting the region to US East 1, and my AWS profile that I'm using is this one. And the profile you use, well, as you can imagine, it needs to be able to do a lot of different things, right? It needs to be able to do essentially the kinds of things you would do via the AWS console. So it's kind of like administrative user. That said, there may be, well, there certainly are some kind of limitations you want to put on that user. You might want to have different users. Let's say you have a different user for the development versus the stage versus production. But in my case, it's fairly simple. One user profile can do all this stuff, all the stuff that I want Terraform to do for me. So in this module configuration block, here I'm telling it what file to look for. Go up to directories and into modules, and then so you get to security groups, SSM, Subnets, VPC. So it can load this one. And then I'm providing some variables, in this case a CIDR block. Let's look at that. VPC CIDR. So I'm telling it, or I'm defining 65,000 possible addresses, IP addresses that can be used within the VPC. Obviously that's lots. It's more than I need, but it's okay. And then we'll get to the subnets in a moment. It's kind of hard to say. For some of these things, you see the interdependence, and Terraform is going to take care. In most cases, Terraform can figure out what needs to be created first in order to create things. It orchestrates all that for you. So you can see that the VPC module needs stuff from the public subnet, or from the subnets module. Well, but let's look at the VPC module, see what's there. So we have this resource type. The first term in this kind of construction is called the type, I think Terraform type or something like that. And then this one is called the name. So here in the AWS VPC, we've passed down the CIDR block that we want to use. We're enabling DNS support, which I've glossed here with this comment, allows instances within the VPC to resolve domain names to IP addresses using the Amazon provided DNS server. Enable DNS host names is true. Allows instances to receive DNS host names that can be resolved to their private IP addresses. We can also, obviously we're assigning tags to make, certainly makes things easier to find in logs, and can make things easier to identify in the UI too. So we're setting up an internet gateway because we want our application needs to be able to access the outside world. So this creates the internet gateway, and we want services and resources within our private subnet to be able to communicate or to reach out to the outside world. So we create a NAT gateway. NAT stands for can't remember what NAT stands for. Network Allocation Table. I take it back. NAT stands for Network Address Translation. And it needs an IP address, so it gets it from Amazon's Elastic IP. So an Elastic IP is created here and then assigned to the allocation ID up here, so that the NAT gateway has a static public IP address. Then we create a couple of route tables, and the first one is a public route table. Again, we're putting it in our VPC. We are specifying a CIDR block, so it directs all outbound traffic to the internet gateway for this route, and then specifies the gateway ID is the ID of the internet gateway. And then for this route table, for our public route table, we make a route table association. So public A, our corresponds to our public subnet A subnet, and then associated with this this public route table, one we just created here. Likewise with public B, and then here we have our private route table, again associated with the VPC. Specify a CIDR block, but in this case the route for all outbound traffic goes to the NAT gateway. And then finally we make our route table association for private subnet A and private subnet B. And then we will need some values from, as Terraform creates this, well, as Terraform directs Amazon to create these things, we get some values, and we need those values to be used by other modules and other places of our Terraform configuration. So we can specify those in this output section, like the VPC ID. Once the VPC is created, it is we have this value coming out, and the VPC CIDR block, the Internet Gateway ID, and that allows us to use them in other places, like here in our Subnets module. We provide the VPC ID, and as we configure our subnets, we need to tell it what CIDR blocks to use for the various subnets. So let's look at the variables section here, and we can see that for each of these, they're getting an allocation of 256 possible IP addresses. I'm not going to go into the explaining CIDR block, but it is a kind of a shorthand format for specifying a range of IP addresses. So here, for each of the public subnet A, public subnet B, private subnet A, private subnet B, they each get some block of 256 addresses. availability zones, I think they're just defined here. Yeah, here. So they are just the two zones within the US East 1 region. So let's look at subnets here. And again, we're specifying the VPC, our particular VPC, the CIDR block for this public subnet, the availability zone. The map IP on launch is not necessary in this case because all the traffic will come from the load balancer. So the public subnet itself doesn't need a public IP. It has an IP, but it doesn't need a public one. And analogously, public subnet B, private subnet A, and private subnet B. So I'll follow the same pattern, and we output the values that AWS returns for those things, the various IDs. Next, we go to security groups, which, as the name implies, are about security. So, and it does so. Well, I'll show you in a second. Notice that I'm passing in a VPN IP. That's not VPC IP. That's VPN IP, not VPC ID. And that is because one particular thing I set up what's called a Bastion server or a Bastion host, so that we could relatively securely access things in the private subnet via SSH from my particular computer and not from any place else. So let's look at security groups. This particular page is a little bit long, but it's an important one. So here we set up a load balancer security group. And because we want, going back to my diagram, where's the diagram here? Going back to the diagram, we want traffic directed there to go to load balancer, traffic directed there to go to load balancer, and then go to their corresponding backend or front-end services, right? So here on port 80, we say port 80 goes to port 80. So we're allowing traffic from port 80 and port 443 for HTTPS access that we'll set up later, and from port 3000 for the API. And then we allow access. This is wide open, so you can go out anywhere you want. The front-end security group allows port 80, but only from the load balancer security group. So that's a way of restricting access. You can't just go directly there. You got to go in through the load balancer. Similarly for port 443, but we can go out everywhere. We can egress everywhere. And then backend security group, port 3000, but only from the load balancer. we set up a database security group. And here you notice that it only says egress. So where's the ingress part? Well, there's another way. There's more than one way to define this kind of stuff. So here, okay, so here's the DBSG security group. So I have this Lambda function that runs the migration scripts to set up the database, set up the tables and columns and all that business. And I need that to be able to access the database. It also needs to be able to get SSM params. So I give it, I allow it. Obviously there isn't any, in this case, there's no ingress to the Lambda security group. There's only egress. It goes to port 443 and 5432, which is further limited to the database security group. So the Lambda function can go out there and run those scripts on the database. So I could have had ingress blocks in here, I think, and done the same, accomplished some of the same thing. Yeah, I could have done it that way too. The Bastion I mentioned a moment ago, that is an EC2 instance. So I needed to allow ingress from port 22, but I'm specifying not a block of IPs, but a single IP, which is the static IP of my VPN. So that makes it pretty secure. And normally, parenthetically, I don't leave the Bastion security group on, or Bastion server on. One, because it costs money. It's the costliest service of all of them. And also because of the security risk. There's no need, and it's only rarely needed, like when I need to debug something. So here's another security group rule. We allow the Lambda to access the database. Wait a second, this might be redundant. Hang on one second, let me think about this. No, I don't think it's redundant. This is talking about the ingress to the DB from the Lambda. So you can see I say port 5432, the source security group ID is the Lambda function security group. And the security group this rule is applied to is the database security group. Similarly, here's the Bastion one. Source is Bastion security group. And this rule is applied to the database security group. And then finally, arguably the most important one, allows the backend to access the database. So on port 5432, my backend application, backend security group can access the DB security group. And then from there, do we output it? What do we output? We output the security group IDs. So I struggle with what order to present these things in, but because everything kind of interrelates, but I'm just going to go in the order of this page. So RDS is the Relational Database Service, and so now we're going to be talking about this area of our diagram where we have a Postgres SQL instance. And our Postgres database is hosted by AWS RDS. And to set that up, we need to tell it what VPC we're using. We give it private subnet IDs. It needs subnet IDs, and we're going to give it private ones because we want it to be in the private subnet. And we're going to give it a security group, which is the DB SG ID. We give it the ID of that security group. And then we can pass in a username and password. And these are coming from the Terraform TFRs file, which I'll show you, even though it reveals the password, and I'll just change the password later. Actually, the whole thing won't be running probably in the future, because this is just a demo kind of project. So there's no reason to keep it all running and have some costs associated with it. But that file, Terraform TFRs, is a file that can hold sensitive values and it can hold sensitive values or non-sensitive values. You could put all your variables in there, but the thing is, you wouldn't want to commit it to GitHub. You wouldn't want to commit it to your repo. So if you're working with a team, it would be problematic to put sensitive values in there. So there are other ways around that that I will go into in a future video. Shared secrets. So you need let's say everyone on a team needs to share passwords or secrets, whatever. Well, you need some way to keep them secure and also make them accessible. So I could talk about that in another video. Where was I? I was talking about the RDS module. Let's look at that. So here the type of thing we're setting up is an AWS DB subnet group. And we're giving it subnet IDs. The private ones or the IDs for our private subnet we're passing in. And then we're setting up a DB instance, a Postgres that we're calling Postgres. And we give it an identifier, and here I'm following a pattern of just specifying the environment and then the name of the project and DB. And I'm specifying, I think this must be the smallest kind you can specify. Passing in all this stuff, all the various needed things, a security group, IDs. So this using the DB security group that I created. DB subnet group name comes from this. What created up here. Okay, I added some comments here on these settings. Skip final snapshot. I don't need a backup before deletion, so I'm setting that to true. Apply immediately, false. This is for modifications to the RDS instance are applied immediately or during the next maintenance window. So that's that. And then I enabled CloudWatch on this for debugging purposes. Does this have outputs? It does. The DB instance ID, DB instance endpoint, DB instance port, DB instance name. And then, this is a big one. Elastic Container Service. So going back to the diagram, we're talking about the ECS cluster. I wonder if I should, let's talk about the ECR first. So the ECR is this part here. Elastic Container Registry. Let's talk about that first. So we've got two repositories, ECR repositories, one called front end, one called back end. I added a few comments there in this file to explain some things. Image tag mutability allows using a tag like latest to refer to the latest version of the image. So when you update an image, that image is just tagged as latest. And the image scanning configuration allows you to enable or disable automatic scanning of container images for vulnerabilities when they are pushed to the repository. And so basically these are the same things, back end and front end. I'm not sure if I think we do use these outputs, back end repository URL and front end repository URL. I think so. So when we look up at ECS, yes, we use those there. Right now I have a headache and I need to take an aspirin. So here we are in the ECS module, which is this business, the ECS cluster. And it's running our Docker images. So we're passing in project name, environment, region, the front end image, the front end repository URL from our ECR module, the database URL from our RDS module, private subnet IDs from our subnets module, front-end security group, back-end security group, load balancer security group from our security groups module. We haven't talked about the IAM module yet, but we'll get to that. It's the role for the task that runs the ECS. No, the role for the ECS task. ECS task role ARN. Again, looks like we need the DB username and DB password for this too. And then the target group, that comes from our load balancer. So we'll get to that in a bit. So let's dive into ECS. Go to the top. So we're defining an ECS cluster, and I'm giving it the name development interview prep ECS cluster. Then we create a ECS task definition for the front end. We define the CPU and memory, giving it the values we passed in for the execution role. Give some information about the container. So this is the image we're going to use. I guess I could add a few more comments on this. That would be helpful. Hang on. Okay, so here's the ECS module, and I just added some explanatory comments that might be helpful. So we're setting up the ECS cluster and calling it development interview prep ECS cluster. Then we create a task definition for the front end. Give it a family name. Tell it the network mode, AWS VPC mode provides each task with its own elastic network interface, ENI, and a primary private IP address, allowing tasks to have full networking features. Then requires compatibilities. I used Fargate, which Fargate is a serverless compute engine for containers that works with ECS. Then I specify CPU and memory. Pretty sure I chose whatever was the minimum. Maybe not. And then again, referring back to the IAM module, which we'll get to later, we'll give it an execution role and a task role, ARN. We have define our containers. So we have a front-end container, and specify what the image is. This essential setting, if this container stops or fails, the entire task is considered to have failed, and ECS will stop all other containers in the task. We do some port mappings. This will, when we add HTTPS, this will have to be changed. Set up a log configuration so we can see some output in the logs in CloudWatch. Set some environment variables. Is this Linux parameter init process enabled? An init process is run inside the container. The init process handles reaping zombie processes, which are child processes that have completed execution but still have an entry in the process table. This can help prevent resource leaks and ensure that the container environment remains clean and efficient. So here's the test definition for backend, and it really is analogous to the front end, but instead we're specifying port 3000, and we're setting a database URL environment variable. But otherwise everything's the same as the front end task. So here's the front end service. I give it the cluster ID and the task definition that we just created above. Here we have a desired count of 1, but we could change that to give more capacity. The network configuration, we're telling it the subnets are our private subnet IDs that we created, and our security groups are the front-end security group and the load balancer security group. And we don't assign a public IP. We tell it the load balancer, which we haven't got to that module yet, but there we're providing the target group ARN from the load balancer module. And then finally, this enable execute command is set to true, and that should allow us to run commands within the container, which can be good for debugging, troubleshooting, and managing my containers without needing SSH access or exposing additional ports. Likewise, for the backend service, we've got pretty much the same kind of thing. We can increase the desired count if we want. Specify backend security group instead of frontend security group. but still specified the load balancer. Everything else is the same. And then finally, I set up this CloudWatch log group for the ECS, so we can have entries in there for ECS stuff. Moving on, let's look at the IAM module. So I'm passing in the account ID, region, environment, and my GitHub repository. Then let's look at what's in here. So we have our ECS task execution role. Some of this stuff I just copied from the Amazon site as like, this is what you're supposed to do. So I create the ECS task execution role, attach attach the role So it's interesting, but you can find when you're trying to explain your own code, it's almost like giving yourself a code review, basically. Well, it is a code review. It's just that you're providing it to yourself. So I noticed that I had, well, start at the beginning. There's an ECS task execution role. Let's see. Role used by ECS agent to perform actions on your behalf when launching and managing tasks. Common actions, pulling images from ECR. So that makes sense. We need that because we want to get the images from our ECR. And the role we attach to that is the Amazon ECS task execution role policy. So that's a kind of standard thing. But then I noticed add ECS task role. An ECS task role is assumed by the ECS tasks themselves. It allows the containers running within the tasks to interact with other AWS services, common actions, reading from or writing to S3 buckets, accessing secrets from the SSM Parameter Store, interacting with DynamoDB tables, etc. Here, because we don't attach any policies, the role does not grant any permissions to perform actions on AWS resources. Well, I don't need my front-end and back-end applications don't need access to other Amazon services. So, but I do need to create the role. Apparently, when you create the ECS, where are we? Come on. When we create the thing over here, when we create the task definition, we do need to provide a task role, ARN. I tried not providing one, but apparently you have to provide one. But in a way, it's kind of like a null thing that we're providing, because I'm not attaching any permissions, any policies to do things, but you do need to provide it. So yeah. Meanwhile, here in IAM module, this might be redundant now that I think about it. Join me now as we look over here to this was the task role. So what I had originally provided was kind of a duplicate of what I had for the task execution role, which didn't make any sense. That's why I questioned it. So what I have here, my policy is attached to this task execution role, Container Registry read only. So I don't think I modified this. I think this is all the standard stuff. And it looks like what you need to be able to get I probably was confused about which thing I should attach, and ended up attaching more than I need. Like they both have batch, get image, list images, describe images. And it's confusing because let's move this up here so it's with its other thing, just to keep them together. Yeah, so it could be that I don't need both of those. Should I try it? Hang on, let me try and see if I can simplify this. So you might wonder, as I did, is this legible? Maybe I need to make this. So hopefully that's legible. You might wonder, as I did, why this policy has EC2 in its name. And so I asked GitHub Copilot. Answer: the Amazon EC2 Container Registry read-only policy name includes EC2 because Amazon ECR, Amazon Elastic Container Registry, was originally designed to be closely integrated with Amazon EC2, Elastic Compute Cloud. ECR is a managed Docker container registry service that makes blah 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 blah. Okay, but anyway, that's why it confused me, that the presence of EC2. And I think my answer about whether I need both, I think is that I don't. This one seems to be the superset. It's got more things. It's a superset. So I wonder which one. Lifecycle policy, that kind of thing, that seems important. I think I'm gonna just I don't know. I could experiment and just try back and forth which one does the job, or do more research. I think I'll just try EC2. What does GitHub Copilot say? Do I need both? I think I asked it if I needed both. Well, let's try it. What the hell? Let's just try using the execution role policy. See what happens. And try not adding this one. Shall we? Why not? See if I break anything. Well, I think to actually test this, I will need to make changes, push them. Commit and push them. Pause the video and I'll resume it when this is done. Although it's running pretty fast. Well, everything ran fine, and the application is still working, right? So, yeah, so this process has led to improvements. Isn't that nice? Where was I? So I just left the task execution, easiest task execution policy. Just delete that. We leave that role. Maybe we'll use it in the future. I have another IAM role called Lambda exec. This starts off the role with minimum stuff, and then give it permissions to do some logging things. Create a network interface. And get the parameters, the SSM parameter. Okay, where was I? I was talking about the Lambda function. This is the Lambda function that does the migrations for the database, to set up the database. We do the log group stuff. This is related to running the Lambda function within a VPC. I put a note there about that. And then we need to get various parameters. This is no longer needed. And then I set up the VPC flow log role, which I was trying to use for debugging. I'm not sure if it was all that helpful, but I created it anyway. The GitHub Actions role is important because I use it, because we have a GitHub Workflow. And I think all this I took as boilerplate from the documentation, where I just customized this part. And I had to customize this part too because I wanted in particular, this was the important part, I wanted to run the Lambda, update the Lambda, invoke the function, get the function configuration. You can see that at work here in ci.yml, update the Lambda function, wait for the Lambda to update, so I'm waiting for the configuration to change to complete, and then invoking the function. There's a Bastion module, which is that EC2 instance that you can use for SSH access into resources in the private subnet. So here I'm setting that up, passing in the VPC ID, the public subnet ID, Bastion security group ID, an AMI, instance type, and then a key name that means the SSH key name. And here is the module itself. So we're setting all that up. And it outputs the public IP. So if I were to open this up and type I would see that the Bastion public IP is this. And I could use that and go over to a terminal. Oops. Is that legible? I don't know. I think it's legible. Yeah, so I could SSH into the instance. I happen to know that the host is running right now because I just looked over here and it says instance state running. So I could just go into that. And then I could, I think I probably, whoops. And I could connect to my database. Is this right? I think so. Paste in the password. And then I could do things like /L, I could do /D. Do /DT, is it? No, or do I mean /D? Yeah, that's what I meant. So I could find out information about my table, that kind of thing. So it's another way of connecting to the database. But as I mentioned, this costs money to keep running, so I can just stop the instance. You still are billed for associated resources, but not charged for some other stuff, so it's a little bit cheaper. Let's go back here. An SSM parameters module. And Right now, I think this is just used in relation to the Lambda function, the migrate Lambda function. So I think what I'm doing is I'm just storing the keys right here, and I've put in the values manually via the console. The Lambda migrate function, I haven't quite gotten to the point I want it to be, but the idea here was to have a generic modules function, generic Lambda function, and be able to customize it to multiple kinds of, or to multiple different Lambdas. But I think actually this is not quite as generic as it needs to be. But anyway, give it the name, its various configuration stuff, the subnet IDs. Notice that it's private subnet ID. The package. So that's a zipped up file. Where ordinarily in the CI flow, the function or the workflow is going to package up the migrations, then run run it. Just this makes the zip file, and then we update the Lambda function. So that's what puts it in the cloud, as it were, or in AWS. Where was I? And if we look inside the Lambda function module itself, or the Lambda module right here, we see that got all this configuration stuff. For the VPC configuration, we've passed in the subnet IDs, the security group, and then I'm giving the function these variables that it can then access, and which it does access here. This is the code for the migrate file, and we can see we're using we're getting from the environment the names of the names of the parameters, and then we use the get SSM parameter to actually get the parameters. So that's how we configure the connection. We have to specify that it is secure, and that's how you do it. That's how you make sure it's secure. This is pretty simple. It just runs the migrations using connects. The migrations themselves, I think I might have mentioned this before, I don't know. They're in this folder, and they get packaged up as per that workflow, copied and then zipped up, and part of the whole Lambda package but these are what the migration files look like. So for instance, here I'm creating a products table, giving it an ID field, name, description, price, a status that it is an enum. And then each migration file has a down, it has an up, and it has a down, so it can be reversed. And then later on, as I was kind of just testing things, I came up with various reasons or various fields to add, like adding favorite song to the users table. And so all this gets run in that workflow. Back to here. This is about setting up the flow log, VPC flow log that logs various kinds of transactions that happen within the VPC. Set up a load balancer. So you can see I'm setting up, it's in the public subnet, so I'm providing those IDs, giving it security group, specifying the VPC, health check paths. And then if we look down into load balancer, we see that, what's all this about? Good idea. I will add some comments to this to explain some of these settings. That could be helpful. Okay, we're looking at the load balancer module. I added some comments to clarify or identify what some of the settings are. Setting internal to false because we have an internet-facing load balancer. Load balancer type is application. You could also have a network or a gateway type of load balancer. We provide the security groups and the public subnet IDs. We have enabled deletion protection set to false. Not sure exactly what would happen or what happens if you set that to true and then try to delete it. Well, presumably you have to do some extra step to delete it. But I haven't actually tried it. I'm not enabling HTTP2. I am enabling cross-zone load balancing, which says set to true to enable cross-zone load balancing. This distributes incoming requests evenly across all registered targets in all enabled availability zones. So here's our front-end target group set up for port 80 and HTTP protocol. Target type of IP could also be instance or Lambda. I have my health check settings here. And that corresponds to where is it? Corresponds to well, actually, I just set it up in the Nginx configuration. So I set up a path And now if I return 200 or okay, so if the web server is working, then that health check will pass. And I think the backend target group is port 3000, protocol HTTP. I actually have a health check set up there. In the backend application, under routes, I have a health route. So return to 200. But an interesting question. The API gateway. Yeah, so, and then there's the API integration side of that. So it would just go to my backend health check. Back to looking at load balancer. I have set up listeners for the front end and the back end. The default action is forward, so it's just gonna. So our API gateway is a proxy. It's just passing everything through. And I make a note here. See how the target group ARN is passed to the ECS service. So we can see that front-end target group and back-end target group are output from this module. And then the ECS service they are provided to the ECS service. And then used in the ECS service. In the load balancer settings, so that's where the target group ARN goes. Same for backend. Back here, that's the end, and that's the end of the load balancer module. Back in the main module, looked at that, looked at that. I think we talked about that. Load balancer, DNS. Did we talk about this already? Yeah, the DNS module. We're passing in the record name, which is dev.interviewprep.onyxdevtutorials.com. We pass in the load balancer name, DNS name, and the zone ID. Same for the back end. So that's all that's in the DNS module. And then the API gateway we already looked at. I think. I think we looked at that. Yeah, we looked at that, right? Maybe Yeah, catch-all proxy for the reading request path. API required, key required, no. This part is a little bit confusing, I find. Proxy options integrate or API, AWS API gateway integration versus AWS API gateway integration response versus API gateway method response. They all sound and kind of look the same, or at least they seem to overlap, But the first one defines how the API gateway should handle the options method for the proxy response. In this case, uses a mock integration to generate a mock response. So this defines what kind of integration to have for the options method. And sets up the template that is used. And here's my comment. In Amazon API Gateway and AWS _API Gateway method response specifies the possible responses from an API gateway, while an AWS API Gateway integration response maps the response from the integration to the API Gateway response. So it's a little bit confusing. This resource specifies the response parameters, headers that the integration should return as part of the integration setup, and tells API Gateway what to include in the response when the options method is called. Okay, so this is again all related to cores, cross-origin, response, whatever. What is it? Cores, cross-origin response. Cores, cross-origin resource sharing. That's what it stands for. So again, this is all related to cores. Is my screen frozen? Wait a second. Oh, my screen is frozen. That's weird. Yeah, my VS Code froze for a minute. So the cores origin we're specifying is the one I mentioned before, dev.interviewprep.onyxdevtutorials.com. Proxy options response. This resource specifies method response parameters, headers that the method should return. It is part of this method setup and ensures that the headers specified in the integration response are actually included in the final response into the client. All right, so all that stuff. Then we specify the API deployment. And here you can see in my comment here, I've made it so that I think I was probably having some difficulty triggering a deployment when I wanted to, but I need to experiment with this further. So the way I've set it is that anytime I do a Terraform apply, because the timestamp is going to change, it's going to trigger a redeployment, which is probably not necessary, and there's probably a better way to do this, but at least during development, that's what I settled on. But just sort of flagged it as something to return to. Then we have the lifecycle setting here. Minimize downtime by creating the new deployment before destroying the old one. Also, I found that I had to use that because I couldn't destroy, or I couldn't do an update because there was a dependency on, something else is using the API gateway, so it wouldn't let me destroy it first. I had to create it first, then destroy it. API gateway has a stage concept. API gateway stage is a logical reference to a lifecycle state of your API. For example, dev, test, or prod. Stages are used to manage and deploy different versions of your API, allowing you to test changes in the development environment before promoting them to production. Again, more things to experiment with probably, and if I experiment further with this project and set up stage and development or stage and production environments, then I could do that. API method settings. The method and path for which these settings apply. Yeah, so you could set up a variety of these settings. In this case, I just have it apply to everything, every kind of method and resource path, and enable the metrics, login level of info, and data trace enable can generate a large, and then my comment is, can generate a large volume of log data, especially for APIs with high traffic or large payloads, which is not what I'm dealing with here. Then something related to the CloudWatch log group. And I have some IAM stuff for the CloudWatch. I just hadn't really figured out how best to organize the IAM and CloudWatch stuff. Like I say here, it should probably be in the IAM module. And then I was thinking that in the future, for a lot of the modules where logging is relevant, a simple flag or system of flags could be good, just to turn things on or off, or set the level of logging from the root module. Could be handy. So that just sets up to CloudWatch policy. And lastly, we get to the custom domain name and custom domain zone ID, which are used in the DNS module. So here we have the domain name of the API. These endpoint types are related to kind of the geographical scope or spatial scope, I guess you could say. Edge is the whole world. Regional could be just within your region, your Amazon region. Or private could be used for like within a private a VPC, private cloud. And the certificate ARN is for the SSL certificate to use with the custom domain. So the last thing in this file is the AWS API Gateway Base Path Mapping, which is used to map the custom domain to the API Gateway stage. And if we go back, it's a lot of back and forth because there's so much interdependency, right? We can see that the output of that API gateway, we see custom domain name, custom domain zone ID, are fed into the DNS module. But they go down there. And that's where they show up. Now, I think I've jumped back and forth from the ci.yml file before, but I don't think I've gone through it top to bottom. The first part of it should be familiar. The workflow is triggered on pushes to certain branches and pull requests from those branches. I think this hasn't changed. This is all about setting up permissions and checking in, checking out. The tests, I think, are the same as in my last video, I believe. Yeah, as far as I can recall, they're all... Well, there is one change that I can remember. Just to avoid DB conflicts, I separated out tests for users versus products. So just run them separately. Otherwise, I thought there could be a problem with the migration and seeding, well, particularly the seeding. Probably more experimentation I could do with that. I found different strategies for handling this situation, where you've got parallel tests running and you want them to use the same database, or alternatively you could set up separate databases. So you could probably experiment more with that. Unit tests can be run together, so that's what I do. And then we get to the deploy section, which is the new part. We do a checkout. Configure the AWS credentials. Set up the role to assume, right? I think we created in the Terraform IAM module. Install the dependencies for the backend. So we do an npm install for the backend. Package up the migration files. So we run where's the file? This file. So we run this file. Copy the migrations folder, this one, into here. So all those migration files into here. So we got that folder there. I mean, obviously it doesn't reflect it locally, because this is happening is in the container that is set up during the workflow, whereas this is my local environment. We cd into migrate Lambda. We removed any old migrate package .zip. Do an npm install. Remove the old dist. Run npm run build. Changing the file name extension to MJS to correspond to the ECMAScript modules, cd into dist, and zip that up. Then add in node modules and package.json into that package. So that's what's going on there. I update the Lambda function. So we call AWS Lambda update function code. Give it a function name, zip file, and our region. And then because that takes some amount of time, I wait for it. I wait for a successful status of successful. But I don't wait forever. I have a max attempts there. And finally invoke the Lambda function for migrations. Okay, but one thing I noticed that I don't need this. It's interesting how much you notice when you actually just talking through something. That shouldn't be necessary. Well, let's just take it out. Because if we look in here, I'm getting these things from the environment that I talked about when I was showing the Lambda function module. So there's no actual reference to it, the database URL. Node environment, yes, but not the other. And this has a connects file in it. So we should not need those things, that thing. And parenthetically, I find the GitHub secrets inconvenient because you can set them and you see the value when you put them in, but if you go to edit them, you can't view them. And so if you don't document what's in there, you have no way of knowing or verifying what's in there. So you have to kind of resave it, if that makes any sense. Set up Docker build X. Yeah, so set up Docker build X. Docker build X to enable advanced build features. Log into the Amazon ECR. We do that. Some of these things I kind of just copied from the Amazon documentation and didn't look into too deeply. Build and push back in Docker image. So our working directory is .backend. We run Docker build using this Docker file, this one here. So I'm doing some setup, some copying things. This looks a little bit more complicated than it needs to be. So this could probably be improved. But it works. So just probably refine that later on. And then push the backend image. Build the image, push the backend image, build and push the front end Docker image. So here we use the working directory is the top level. Which means we're using this Docker file, which is a little bit confusing, but maybe I can make that less confusing at some point. So we're setting up Nginx is the important part there. And then finally, we update the service for the ECS service for the backend, update ECS service for the front end. And then all this crazy stuff miraculously works. Well, let's just see how well it runs. Whether it still works after all these little changes I made while making the video. If I didn't mention it before, you can do Terraform plan first to see changes before you apply them. But this will also show you what's going to happen. I think most of the changes at this point are just related to comments I made, and therefore the only thing that's actually changed is the API because of that timestamp trigger. So that all ran. And then not a good comment here, or commit message, but whatever. I have a cold, and so that gives me special dispensation in GitHub. Let's see if anything craps out. So let that run for a while. So the workflow is still running. Let me switch over here. I think I covered a lot of what I wanted to cover, and since this video is probably already too long, I might leave the rest to another video. In my README, I cover things like running the app locally, running tests. I pretty much showed running tests previously. There are some updates, I think. There might be some updates in how you run the tests since the previous time. There's something about about making new migration files. Anyway, hopefully there's something in all this that you will find useful, or somebody someday, somewhere will see this video and find something useful. It's useful to me to make it, so that's all I have to say. Let's let this continue a bit more. Right, so that all ran. I mean, the workflow ran. Application still runs. So all is good. I can't remember if I showed the AWS console for ECS services, but that's this. So we can see that things are active and running. 0, this is backend, 0 pending, 1 running, shows deployment status in progress. So actually, it's probably the old version running still. This new version is coming online. Generally, it's pretty fast, and well, I guess it's done. So yeah, even though you're working with Terraform and making changes in Terraform and kind of orchestrating everything there, the AWS console is still here. The thing is, if you make changes via the console, you'll need to import them to some kind of, well, usually it's just a matter of importing them. I have at times had to use commands. I think I wrote some notes here someplace. Yeah, useful Terraform commands like destroy, adding using init. I believe that's necessary when you create a new module, so that's when I would use that. You can also use destroy, taint, import, state. So these are all important to review and experiment with, I think. I have a section here on costs. As I mentioned before, the EC2 instance was really the costly thing. The others are fairly trivial. Of course, this is only a demo kind of project, so I don't really need to keep it running. I can just tear it down completely. But something to watch out for. You can set an alert in AWS. If your costs begin to reach a certain threshold, you can get an email or some kind of alert to warn you about that. So it's not all this stuff that I created is not within the free tier. So I think that's all I'm going to say for right now. And I'll think about what to put in the next video. One thing will be just making the web server HTTPS. Don't know what else I'll do, but we'll see. Have a good day.